Hello! In this video, we will find the inverse functions and we will see when we need to interchange the variables. So consider the function y equals 3x plus 6. This function has two variables x and y, and we typically think of x as the independent variable or the input. Y is the function, or we can call it the dependent variable. In the rectangular coordinate system, we relate x to the horizontal axis, which is the x-axis, and y to the vertical axis, which is the y-axis. So here we can say that we have y as a function of x. And if we replace x with any value, then we can find the value of the function. For example, when x equals 2, y equals 3 times 2 plus 6, and all this makes 12. We can also say that the point 2, 12 is a point on the graph of this function. So again, in this function, we had the input 2 and we got the value of the function 12. But what if we are given the output 12 and we need to find the value of the input? For this, we need the inverse function. But to find the inverse function, with one method, we start right away by interchanging x and y. So in place of y, we will write x, and in place of x, we will write y. So now we have x equals 3y plus 6. Then we solve this equation for y, so we will have 3y equals x minus 6, and we divide both sides by 3, and we will have y equals 1 over 3x minus, and 6 divided by 3 is 2. So now we have the inverse function solved for y, and if in this function we replace x with 12, the value of the function will be 2. So when x is 12, y equals 1 over 3 times 12 minus 2, and 1 over 3 times 12 is 4, and 4 minus 2 is 2. So now we can say that the point 12, 2 is a point on the graph of the inverse function. And now if we compare these 2 points, we see that the x and the y values are interchanged. Now we can also find the inverse of this function by solving it for x first, then interchanging x and y later. So if we solve for x first, we will have 3x equals y minus 6. Then if we divide both sides by 3, we will have x equals 1 over 3y minus 6 divided by 3 is 2. And now we interchange x and y, and we will have y equals 1 over 3x minus 2. So as you see, when we find the inverse of a function, we can start by interchanging x and y first, then solve the function for y, or we can solve for x, then interchange x and y later. But now let's consider a real-life situation, for example, the distance function as a function of time t. So let's say that a vehicle is moving at a constant speed of 60 miles per hour. Then we can say that the distance function is d equals 60 times t. In this function, t is the time in hours and d is the distance in miles. We can also say that t is the independent variable or the input, and d is the dependent variable or the output. So we have d as a function of t. If in this function we replace t with 2 hours, then 60 times 2 will be 120 miles. So in 2 hours, the vehicle will travel 120 miles. And if, for example, t equals 3, then d equals 60 times 3, which makes 180 miles. So we can say that the point 3, 180 is a point on the graph of this function. And if we would graph this function, then the horizontal axis will be the t-axis and the vertical axis would be the d-axis. Now, what if we are given the distance of 180 miles and we need to find how many hours it took the vehicle to travel this distance? For this purpose, we need the inverse function. Now, to find the inverse, I will take the distance function d equals 60t and I will solve it for t. So, if we divide both sides by 60, then we will have t equals d divided by 60. And this is the inverse function where the input variable is d and the output variable is t. And if we replace d with 180, then indeed 180 divided by 60 is 3. And notice that when I found the inverse of this function, I did not interchange t and d, and instead I just solved it for t. And that is because in the inverse function, we still want to call the time t and the distance d. And if we would graph this function, then the horizontal line would be the d-axis and the vertical line would be the t-axis. But what if in this initial function, in place of t and d, we would like to use x and y? Then we would write the function y equals 60x. And now to find the inverse, we can solve for x first, so we will have x equals y over 60. And as you see, these two expressions are the same. And what we have here now, we have x as a function of y. But the problem is that when we use x and y, we typically use x as the input variable and y as the function. And that is again because how we relate x and y to the rectangular coordinate system. If in this function we keep y as the input and x as the output, then we would need to call the horizontal axis the y-axis and the vertical axis the x-axis. And to avoid this confusion, we just need to interchange x and y. So if in place of x we write y, and in place of y we write x, then now we have the function y equals x over 60. And now in this function, x is the input and it is related to the horizontal axis, and y is the output and it is related to the vertical axis. So if we have functions that have variables that are related to specific quantities, then to find the inverse, we just solve the function for the input and we don't interchange these variables. And if in the initial function, the horizontal axis was the t-axis and the vertical axis the d-axis, then in the inverse function, these two axes will interchange. However, when we work with x and y, we typically want the horizontal axis to be the x-axis and the vertical axis to be the y-axis. That's why, in this case, we need to interchange x and y. I hope you found this video useful. Please give me a like and thank you for watching.